we've learned that an atom can emit light. How does this happen? You take the electrons, excite them to a higher energy level, and a short time later they fall back down to the ground state. When they fall down, the energy they had up here goes somewhere, and it turns into a photon, a packet of light, which carries the energy away, and we can calculate the energy of the photon with this formula. So how do you get the electron to jump up in the first place? Do you shine photons on it? Well, yeah, that's one way you can do this, excite the electron. But another way to excite the electron is to generate an electric field and put that atom inside an electric field. That's what hydrogen lamps do. A hydrogen lamp is a lamp that contains a bunch of hydrogen gas. Here, each of those is, another hydrogen molecule, and it has an electric field running through it, and that electric field oscillates back and forth. It's an alternating current, but we're not going to learn about that. And so now those electrons in these atoms are getting excited, and they fall back down, then re-excited, and they fall back down. So this hydrogen lamp emits light. Photons come out. But the green photons are mixed with the purple photons, which are mixed with the red and the blue. It's all mixed together. So before we can see the individual colors that are created, we have to pass this thing through a prism, right? So the light passes through the prism, and then finally the colors are split up. Let's see. Something like this, perhaps. And now we can observe the individual frequencies that are produced. If you take those frequencies of light, you could plot them on a wavelength graph. You could have red all the way up here. That's a higher wavelength for red. Blue is a lower wavelength. And green, maybe somewhere in the middle. And so you could actually plot the various wavelengths that are emitted. If you have shades of green, you could put those in. Maybe there's another shade right here, rather. So you can plot what those look like. This is called an emission spectrum because we are looking at the spectrum of light emitted by the atom. Oops. Okay. However, there's another way to do this. You can also generate an absorption spectrum. That's by having the light absorbed by the molecules or the atoms. So you start out with every color. Imagine this is completely filled in, right? You've got reds over here. You've got greens perhaps in the middle. This is all, it's like a continuum, Blues here. And you send all of that light with all of its colors through some gas. Here's a hydrogen gas with the molecules inside. There's no electric field this time. Instead, we simply send white light through. As the white light passes through the gas, certain frequencies or certain wavelengths will be absorbed. Why? Because, whoops, where'd it go? If we look back to this picture, here's the electron hanging out down in the ground state, and you shine some blue light on it, and you shine some red light on it with a bigger wavelength, and some green, which is in the middle. And, the red comes and hits, and it just passes right on by, because the red does not have the right energy to promote the electron to exactly this level or exactly this level. The red has too little energy. It would put the electron here, and you can't have the electron in that forbidden space. So the red passes by, it's not absorbed. The green comes along, and hey, that has just the right energy to pop the electron to the second level. So green gets absorbed. The blue comes along and hits a different electron, maybe from a different atom altogether, and it has just enough energy to pop the electron up to this higher state. And so the blue gets absorbed. What do we notice? Certain colors pass through, and other colors get absorbed. So when you look at your white light, what started as white, well, now, right here, some of that light is missing. How can you tell which colors are missing? You send it through a prism. So this is harder to draw. Maybe I'll just put a bunch of lines here for all the various colors, whatever they may be, the full spectrum. And how do I show some are missing? Well, the blue would be missing, right? So maybe I'll do a dotted line to show it's not there anymore. It's a ghost of color. The red is missing, and the green, if it's the same, that would be missing. And so we would start what would we do? We would look down here. We would say this purple that was here, there's a missing line. And the blue here, that's missing because it got absorbed by the atom. And the greens that were here and here, they got absorbed. And this red right here got absorbed. Now, this is not I haven't done a great job of showing you what the spectrum looks like. So let's see an actual example. If this is what the emission lines look like, you say, oh, hey, here's a line right there. There's a line right there. Here are the lines. Then the absorption lines, would look the exact opposite. You have the full spectrum coming out, but certain colors, certain frequencies have been absorbed because they were absorbed by the electrons. Their energy, this HF, exactly matched a delta E for the electron. This HF exactly matched, of that photon, exactly matched a delta E for the electron based on its energy levels. So yeah, so that's sort of what happens here. Okay. How do we concisely put this down? Well, you've got white light sent through some hydrogen gas, or any gas that you want to test. We'll call it hydrogen. That's the typical example that we use. The light emerges. Some colors are missing, but to tell which ones are missing, we send that light through a prism. So the colors come out the other side. Some colors are missing because those photons had an energy HF that matched a delta E, the change in energy between two levels, two energy levels. For that electron, for the electrons. We'll just put electron singular. Okay. That's what we see. Pretty cool. Notice how this is kind of a perfect complement of the emission lines. They show the same colors, it's just whether they show the colors that were emitted, and you see them right there, or they could show the colors that were absorbed, and then you see black lines for those particular frequencies of light.